My goal for us is that we can give talks and they can be intelligent and elevated, and we can talk about machine learning and how our models worked, but hopefully we can also talk about what the data we used is, how we got it into a structure that we could work with, and kind of, how we deal with these unstructured data sets or how we deal with these unnormalized data sets. So regardless of if you're in academia or the industry, I feel like we're dealing with a lot of these messy data problems silently or just by saying, after I processed the data, then I was able to train this model. So sometimes I feel like I'm the only one with unnormalized data, and everybody else has this amazing normalized data. So could you raise your hand if you've dealt with normalized data within the past year that was completely normal? Okay, in the past 6 months, keep your hand up. In the past 1 month, keep your hand up. Okay, so this is a problem. So I know I'm not alone. A simple search on Stack Overflow for really any type of data wrangling or data cleaning topic shows that yes, there are tens of thousands of people with these same problems. And so I feel like we need to embrace these problems and have conversations about them. I mean, you're all here, but we have to worry about the people out there. So the first step in terms of determining messy data and what to do with it is knowing your data. If you're working within your domain and you're a domain expert, then you probably already know a lot of this. But let's say you're dealing with a new data set, or let's say that you switch industries or you're working with a new team. You might need to ask some really big questions about the data. You want to know the data source. You want to know the methodology. How is it collected? What are the likely values? What are values that might bring you pause? These are all things that you have to have a conversation about before you dive into data analysis. You need to know, has it been normalized? Should it be normalized, right? If you're looking over, say, measurements collected over the past 10 years and it has anything to do with currency, or it has anything to do with any other variables that might have changed over time, then you have to start thinking about these questions. How am I going to standardize the data? How am I going to normalize it? And also, ask yourself questions. What's significant? If I find that there's more sunglasses sold in the summertime, that might not be a significant data point, depending on what I'm trying to ask. So I found this Geek and Poke comic, and for me, it was funny. And what I think I'm trying to say here is you should know what's relevant and what's significant. And sometimes they're not the same thing. But also, ask yourself questions. Does it matter that it hasn't gone above 100%? In this case, no, right? So focusing on what's relevant will help keep you focused on what to clean and how to deal with these messy data sets. So one of the biggest problems that you'll face when dealing with either understructured data or unstructured data is that you have missing data. So once you've cleaned it and you pulled it together, you find out that there's null values or that you're missing significant data points. This could mean that you wanted to collect all the data points for the EU, and let's say you're missing Germany. That's going to be a problem for your analysis. If you're also missing critical data points for your exact question. So say you have 80% of the data collected, but the 20% that's missing is actually dealing with the question that you wanted to answer. That's also going to be a problem. And then if you're dealing with missing data, say you have time series, is there a way that you can fill in the data? So using pandas or a lot of other different tools for data analysis, you can choose to backfill, forward fill, or fill with some sort of value. If you're dealing with these situations, that might be the best bet. So when you're dealing with missing data, you need to know the possible null values. If you find that, say, 10% of your data set is the same exact number, and that number is not a likely value, then it's likely that that might be a hidden null value. So if you don't know the origin of your data or how it was collected, then beware of those odd or strange values. If all of the values are a bunch of nines or a bunch of zeros or something like that, that might signify something. And when you're cleaning your data, keep an eye on statistical significance. So if your goal is to answer a question with a particular piece of your data or with a few different values and say, look at their correlation, and you end up with only 20% of your original data set represented, you may have essentially cleaned your way out of being able to answer that question. So another problem that we often face with messy data is duplicated data. And so you should know, again, you should be a domain expert, or you should know when potentially you're dealing with duplicates. So it could be that you yourself inserted the problem into the data set. So you did some batch processing, you ended up bringing in one batch twice. That's a problem that you created, right? It may also be that whoever collected the data for you did something like that. So know which duplicates are intentional. So I wanted 3 different data points for this particular timestamp, and know which ones are likely human error. You also might need to determine your own unique keys. So depending on the data set, I've done a lot of work with government data sets, and sometimes they have an ID field, and you feel like, this should be easy, this is my unique. And that's just not the case. It ends up that that ID field represents that particular time point in the survey, and there's actually 3 of them because there was 3 different locations where the survey was given. So know about how to create unique keys or groupings. You can also utilize the dedupe library. So this is a library that tries to match essentially messy strings and match them together. So it can match potentially 32 kilometers with 32 km. This is the goal of that library. And you can also use fuzzy matching. So who here has used Fuzzy Wuzzy by SeatGeek? It's a really useful library that essentially measures string distance, and therefore is great for dealing with, say, misspelled data, or when you're dealing with user input data. So you can also, when you're dealing with user input data or survey data, have inaccurate data. So I don't know how many times I let Chrome autofill something or this or that, and it's an address of some place I lived at 3 years ago. So these are problems that you have when you have users inputting data. It could be bad values, it could be inaccurate zip codes, let's say, or incorrect country codes. Your data could also just be out of date. So Julia Evans mentioned yesterday that, depending on how often you update your data, you could have inaccurate DNS records. So Dilbert is one of my favorite comics, and this is a situation I can relate to. And so basically in this situation, you're dealing with inaccurate data, and for whatever reason, the data is wrong. And I think that this is a situation hopefully you can also relate to, or you've been in similarly, and it's about being able to have a conversation. If you're the manager, then being able to ask questions. Well, why is this data false? Why do we still have it in a database somewhere? How can we make it more accurate, right? And if you're the engineer in this situation, then potentially it's about informing, managing up, if you will. And it's about informing other teams that you work with, hey, the data collection methods we're using for this measurement are inaccurate and false, and we should do something about it. Messy strings are potentially the worst thing about being a Python data wrangler, and they're all over the place. I have a long history in web scraping, and if you've scraped any data yourself, then you know that there's a difference between actually having your scraped data and being able to accurately apply it. And so having the data and having the data in a form that you can ingest it and do analysis are 2 different things. Again, fuzzy matching and dedupe can help with these. I know that everybody hates regex, or maybe not everybody, but I feel like the people that love it might just have Stockholm syndrome or be Perl developers or something like that. But everybody hates regex. At the same time, it can be really useful. So if I know I need to pull out a phone number from this string and it's somewhere there, I usually turn to regex. So it can help. I would not say that it's for every problem, but it can help for the problems that it's good at. If you know what data types you can expect, then this can help a lot too. So if I know that I'm expecting floats and I'm seeing strings, then I know that I have something that I need to clean up. And determine what you really need. So if you're dealing with really messy strings or unstructured data in string format, then determine what you actually really should work for and determine what can just go by the wayside. You don't need to clean everything, right? So encoding woes. This has been a problem for a long time. If you're using Python 3, I hope it's less of a problem for you. If you're using Python 2 still, I highly recommend importing Unicode literals. I'm sorry for the Celine Dion reference, but hopefully it won't be stuck in your head for the next 2 hours. But this Unicode code byte is here to represent a heart emoji. So I asked Ned Batchelder if I could use one of my favorite slides about Unicode, and it's this. I say embrace the Unicode sandwich. And for that reason, you need to know all the entry and the exit points of your code for any sort of data I/O. And you need to know if you're building a library that handles I/O for me, then I'm expecting to hand off Unicode to you, and I'm expecting to get Unicode back. If you're not a library maintainer, then you should be expecting the same thing, right? And if you're not getting that, then A, you should be filing a bug with the maintainer, but B, you should also make sure that you correct for that. So it's about knowing all of those entry and exit points and make sure that you're using Unicode on the inside and bytes on the outside. And you can do this regardless of your Python version. So another lovely topic is dealing with measurements and metrics. So I hope, since I'm in Germany, that most of you are dealing with actual metric data. But how many of you have to deal with data sets that are sometimes imperial? No? Okay, that's amazing. Well, I'm sorry for you. So regardless of the data measurements, you may have data sets that have more than one type of metric used or more than one type of units. So you should know that. You should know what values you plan on doing your analysis in, and you should determine how to reach that standard before you get knee-deep in data analysis. And so think about how you can convert, how you can standardize, and make sure that you make notations of how that was done. Because if other people are trying to replicate your research or replicate your analysis, they're going to need to know, hey, by the way, I chose this one standard, I converted all of my data to it, and then I moved on from there. This is a comic I found about outliers by Ben Shabbat. He's a grad student somewhere, and I found it both funny and relatable. So on the topic of outliers, yes, I know that the standard practice is we need to remove them so that we can find the overall trend, or we need to remove them so that we can do actual real data analysis. But I'm also a big fan of determining when is the outlier actually important? When am I, let's say, overfitting? When am I just choosing or inserting my own biases on my data set and determining, no, this line is great. I don't care about these ones that don't fit. So if you're going to remove outliers, take a moment to actually look at them first and determine, is there a story here? Is there something here that's significant? And if so, sometimes that can actually be the focus of your data analysis rather than whatever it was that you initially imagined it being. So if you're dealing with funny file formats, how many people here have to deal with PDFs or audio files or video files? It's not exactly as bad as it used to be. So I recall talking with folks years ago at a conference about using using basically Linux system libraries to try to compile audio and necessarily like find interesting pieces in the audio by using system tools. We're obviously very much further than that. That said, AI and machine learning are not necessarily always the best tools, but they have developed quite a lot of things for us. If you're dealing with funny formats, if you're dealing with PDFs, I mentioned them and showed a little bit about PDF tables at my tutorial yesterday, but I highly recommend it. It's not yet ported to Pi 3, but it does actually work for extracting PDFs, or sorry, extracting tables from your PDFs. PDF Miner is also really useful, and it has a PDF to text tool. If you just need the text from the PDF, then that's what I would recommend doing. And Textract deals with PDFs and a bunch of different data formats. So if you're dealing with images, I've read a few good things about Octopus. And there's a bunch of free OCR APIs, so I've dealt with this problem a little bit in the scraping world, and I find that quite a few of the APIs work very well. If you're dealing with speech, then the speech recognition library, I highly recommend. What it does is it gives you basically a simple client interface where you can talk with either IBM's Watson, a bunch of the Google speech APIs, as well as a few different other ones. I believe Bing is in there represented. But you can get speech to text really easily with that. And has anybody taken a look at Take Note For Me? If not, you should. It's a project by Xinlu Huang, and she's an Insight Fellow studying theoretical physics. And she built it. It takes YouTube videos, or really any video, that's a professor writing at a blackboard, and it uses image processing. I believe she actually uses scikit-learn to pull just the text and take the notes for you. So it's pretty neat. Right now, I think it mainly works on Blackboard, like black-based, but I think she said she was working also on a whiteboard option. I highly recommend taking a look. It's fun just to play around with, even if you're not a physicist. Beyond that, I think that one of the biggest pieces is using common sense. So if you have a data set and it says that a man is pregnant, you need to ask yourself, is this making sense? Or is this data possibly wrong? If you're looking at a data set and it's normalized, or it has a normal distribution and you are expecting that not to happen, then you need to decide, has this been pre-processed? Is this data wrong? So you can always check these types of things. I recommend doing a quick histogram and other things when you first import your data, and check also for correlations you expect to see. So if you correlate height and weight and you see that's completely off, then is the data properly collected? Or maybe do you have the measurements right? So if you expect to see some of these correlations, or if you expect to see different correlations, then you might want to take a look at those first before you begin to use your data set. So speaking of correlation and causation, this is a fun XKCD comic. So if you use common sense with your findings, you're going to determine when, say, it's a population map, or when your data is, say, over-representing for something like simple numbers, and when it's not biased, right? So you need to make some conclusions by using your brain, using what you know, and applying that to your data. By answering these questions, you can determine, can I still use this data set, which you probably can, but do you need to maybe think about how the population might skew the way that your data was collected? So before you draw massive conclusions from it, you need to determine, okay, how is my data collected? Is it over-representing? And answer those questions first. So in preparation for this talk, I decided to try and consume as much messy data as I could find. And in doing so, I also decided to read some academic studies. And I dove into recent papers. Recent in academia, by that I mean 2013 and up. And I found a lot of interesting things. One thing that I found is that unsurprising to us as it should be, many different parts of academia are now applying machine learning concepts to messy data sets. And they're actually getting really great results. So there's some really interesting papers out there and great ways to look at implementing machine learning and data cleaning, as well as applying functional constraints to your data sets as a way of solving this problem magically. So if you're already using, say, like an enterprise data wrangling tool or an enterprise data warehouse, I don't know what you're paying for it, but probably some of this is actually already happening for you. If you're not doing that, then the good news is that it's very quickly on the way. So this is a graphic from continuous data cleaning, which was one of my favorite papers that I read. It was by Volkov, Chang, Schlitzcha, and Miller, and it was published in 2014. And what they decided to do is they had a series of functional constraints. So this is essentially saying something like, there's a zip code and it just maps to one city. And by applying these different functional constraints, then they can flag when data doesn't fit. When data doesn't fit, then they can they can use classifiers to make repair type predictions. And they use a cost model as well to decide, is this repair costly or not? Is it gonna require me to clean 10 rows or just 1 row? Then it makes decisions on that and recommends repairs to the user. Now this is an interesting part, and this greatly increased their likelihood of getting it correct. They then use the user input data, so the user says, okay, this looks right, or that looks right. Then with that data, they were able to retrain the classifier. Using this approach, they were able to reach 90% accuracy. So I think that this is something that's on the horizon, if not actively being used. And for that reason, I believe some of the people who wrote this paper are working for IBM now. But I do think that this is something that we could also try within the PyData community. We could try and determine what are the functional constraints for our data set. How can we then map them and determine, is my constraint broken or is the data broken? And how can we then apply machine learning and use machine learning algorithms and advancement to make this even better? So I want to say thanks. I know it's a bit short, but if you have any questions, you can either ask now or you can reach out. If you're interested in a little more of the papers that I was reading about, then I can also pass them along to you. You can find me at KJam on both GitHub and Twitter, and you can also find me at kjamistan.com. I also really love talking about messy data, so if you have a particularly messy data set that you want me to take a look at or that you're willing to share, then that's a favorite pastime of mine. So, thank you.
Thank you very much, Katharine. Any questions?
Thank you very much for your talk. It was really enlightening. Can you recommend any good libraries for detecting unknown encodings of files?
Yeah, so that's a big problem, obviously. What I would say, or my first advice is to attempt, I have several things that just attempt the 10 most common encodings that I see. That's, I think, probably the best way. You can test for the Unicode, or you can test for the UTF start byte, is a lot of times how I do that as well. And there is a new way in Python 3. I would have to look at the exact name of the documentation, but there's something that tries to magically guess. The really hard thing about this is that there are code points that are represented in numerous encodings that are different. So you've probably experienced this as well, where you think, or it has a code point that maps to this, and then you find later that it's actually been decoded improperly. So I think that there's no magic yet. I would say that with a few intelligent guesses, you can usually get it down to 3 or 4 different possibilities. But from there, I think applying some of the common sense of what's likely, depending on the origin of the file, what's most likely is usually the best way.
Okay, thank you very much.
No problem. Other questions?
I would like maybe to ask you to tell about particular data set that you were working with that the cleanup turned to be either insightful or surprising.
Yeah,
Or insane.
Yeah, of course. So I worked with quite a few data sets when I was I wrote a book for O'Reilly on data wrangling. In doing so, I worked with a lot of different data sets. A lot of them were government data sets. They were really messy and awful, and a lot of times I spent hours and hours cleaning them, only to find that there was absolutely no correlation between the two things I was trying to take a look at. So I probably went through 20 or 30 different data sets on a variety of social indicators in Africa, trying to find links between certain social factors and other social problems, and found absolutely nothing. So I eventually found something that dealt with government corruption, allowing for an increase in violence, and that was the link I finally found. But what I'm trying to say is most of cleaning data is a lot of unthankful work. Just thankful for yourself that you got through it. But at the end, usually you'll find something that makes sense. So stick with it.
As a company, in your experience, which are some of the techniques and the practices that you could put in place to prevent ingesting like messy data or producing messy data?
Yeah, so hopefully if you're producing the own data that you're consuming, you can have some influence on what's actually produced. But if you can't, or say it's another team, or it's just messy log data, then I would say that pre-processing is key. So before you go ahead and store your data, see how you can optimize in a performance-friendly way about pre-processing that data in some way, shape, or form. So for example, with PySpark, with streaming, you can do some cleaning depending on how performant your Python code is. You can do that before you actually send it to Hadoop or wherever you're storing your data. So I would say the biggest problem that I see that people have is they've stored all this data somewhere and nobody bothered to pre-process it, nobody bothered to post-process it. So you have this massive database or this massive data set of really messy data, and if somebody had just taken time to even just do some simple string parsing before it went into the database, then there wouldn't be this problem, right? And once it's already in the database, then it's a whole other problem trying to extract it and clean it and reinsert it, right? So depending, especially if you're dealing with production systems, try to implement a solution sooner rather than later that gives you data that you can actually work with. And this might mean, yes, like messing around in production with things that you don't necessarily want to touch. Hopefully you have a good staging environment or something else representative of the data that you're processing. But I would recommend overall just focusing on pre-processing it and focusing on making that as performant as possible.
Hi, just wanted to ask you whether you have any experience with the Apache Tika for text extraction from documents.
So I have not used that. I have heard mixed results, but I haven't tried to use it for, I think that probably the biggest problem in PDF or text extraction from PDF-like documents is not the text itself, but it's the other things, right? It's like the images, the charts, or the tables that are the most difficult, because when you pull that out via some sort of image recognition, or when you try to locate those using the actual PDF miner tools to locate them, it's often just like really unintuitive, I would say. And so, yeah, if you have good experience, have you used it yourself, or?
Yeah, I just found that there are Python bindings for it and dabbled around a bit with it, but just for text and not anything else like you mentioned.
Yeah, so I think text is kind of a solved problem with PDFs right now, which is great. It's more, I feel like the very unsolved bit is getting tables, getting data out of tables and other things like that, or images, particularly difficult. But I'm really hoping that kind of with the speed that we're moving in terms of image recognition and image processing, that will just become a thing. I can say on page 37, there's this great chart, please extract it for me, and the image processing libraries that we're getting can then do that, basically from a PNG or something like that.
Thanks.
Okay, so if there are no more questions, so thank you again, Katharine.
Thank you.
And